Hi, welcome to the Play Framework video course. My name is Martin Gontobnikas and my Twitter and GitHub accounts are mgonto. In this course, we'll learn all that we need to create fantastic web apps in Play Framework 2.0. Today, we'll start with the first section of this course. In this section, we're going to learn the introduction to Play. In this section, we're going to take a look at the current problem. How do we build web apps right now? Then we're going to learn what is Play and what it stands for. Then we're going to see Play in the real world. We're going to see real-world examples and we're going to compare it to other frameworks like Ruby on Rails. So let's build a web app with our current Java knowledge. The first thing we need to do is to carefully select the framework and tools we're going to use. Once we choose them, it's very important that they work okay, as changing them in the middle of development is really hard. So, what are we going to need? We're going to need a web framework. For that, we Java developers are used to Spring MVC. Then we're going to need some inversion of control and dependency injection. For that, we're going to use Spring. Then we're going to need some persistence API that abstracts us from all that we need to do with the database. For that, we're going to use JPA. Then we need some ORM. We always want to save things in the database, but we don't want to do SQL queries. We want to use objects. For that, we're going to use Hibernate. Then we need some templating engine. We need to be able to create HTML files using variables sent from our controller. For that, we're going to use JSP. Then we need to be able to reutilize views. Sometimes the header and the footer are the same in all of the pages and we don't want to create them every time. For that, we're going to use tiles. Then we need a server container. It will have our web app and it will make us possible to show the web app to other users. For that, we're using Tomcat. Then we also need to create mock for tests, as we don't want to make end-to-end tests. For that, we're using Mockito. Then we need to manage dependencies. We need to be able to set the version and to download dependencies of our applications automatically. For that, we're using Maven. With this, we have all that we need and all that we want to build our web app. Once that we have selected this, it's time to configure Hibernate and Spring MVC. So, let's actually do that right now. Here you can see two XML files and properties which have all the configuration for Hibernate and Spring MVC. As you can see, it is a very big file, and this is a lot of boilerplate. We actually define this every time we create some web app, and it's not really that necessary. So these are 730 lines of configurations with both XML and properties. Here we can see that right now, in order to create a web app, we have to learn a lot of technologies and we have to write a lot of boilerplate code to get us started. This is the biggest problem we have right now. Today, we have summarized the current problems when creating web apps with Java. Play Framework has been created to solve all of these problems. This is what we're going to learn throughout this course. Next, we're going to learn what is Play. So, now we've got an idea of what is the problem when creating web apps with Java right now. Fortunately, Play Framework was created to solve all of these problems. Let's see what Play is and how it's helping us to create web apps easily. Play Framework was created by Senexity in 2007. It was created for internal usage. It was used for creating their web apps. Once they realized of its potential, they decided to make it available for all of us. They made it available on GitHub. Play is an integral framework. This means that Play has all of the tools and all of the frameworks that you're going to need to create a web app. This means that this has a persistence API, this has a testing framework, a dependency management framework, and all of those. Play framework was created to be used in real-time processing applications. Play framework intends to solve one of the most common internet problems, which is called C10K. This is the concurrent 10,000 users in an application. Play framework handles all of them. So why is Play framework so popular right now? Play framework was created, as I said before, to handle real-time applications. Right now, the web needs real-time. The web needs to handle thousands and millions of requests per second, and the data that the users are creating needs to be available in that exact moment that they are creating. Let's see, for example, Twitter. When I tweet something into my timeline, I want that to be available to all of the users in the world and to all of the people who are following me. That needs to be done in that moment, and millions of users are accessing Twitter in each second. Why is this so popular? Right now, TypeSafe, which is the company that created Scala, has given support to Play framework. This has made it possible for Play framework to be used in some of the most important web companies in the world. This is making it so popular. So why should I learn this? Well, there are two main reasons. First, Play frameworks makes us all be much more productive, as it is an integral framework. You need to learn Play to create web apps. The second thing is that it is so easy to create real-time applications with Play that it is awesome. So, let's create a web app with Play framework right now. Let's check what tools and framework we're going to need. We're going to need a web framework. We can use Play for that. We also need an inversion of control and dependency injection. Do we really need those? I mean, we as Java developers are really used to using them, but sometimes we don't even know why we're using them. And in most cases, we actually don't need them if we add all of the behaviors in the models, as we're going to see later. We need a persistence API. In this case, we're still using JPA. We also need an ORM. For that, we use Play. Play internally uses even, but we're using Play. We also need a templating engine. Play comes with one. We also need to reutilize views. Play comes with that as well. We need a server container. Play is a server container as well. We also need mocks to test. Do we? There are a lot of people who hate mocks and who said that we need to test with real objects. Play helps us create real objects very easily, as we're going to see later. So, do we really need mocks? And we also need some way to manage all of the dependencies. Play handles that with SVT. So, now that we have chosen everything, let's configure a new web app with Play framework. This is the configuration for Play Framework's XML. As you can see, there are just 13 lines of code, and they are very clear. There is no boilerplate in this case. And in this case, we just have one properties file. We don't have any XML. Now we can start to understand what Play is all about. In the next section, we're going to see Play in the real world. We're going to see real-world examples and we're going to compare it to Ruby on Rails. Hi. Now we know what Play is, what it stands for, and what problem it solves. Today, we're going to learn about using Play in the real world. The first thing we're going to learn today are great things for everyday coding. Play is very easy to configure. It uses convention over configuration to set safe defaults for everything. However, we can change these safe defaults and configure the app however we want. That is why Play is highly configurable. It is also extensible. We can create modules that extend Play functionality and we can then reutilize those in any web app that we make. It also has a quick turnaround. When we are coding, we don't want to restart the server every time we make a change to see if it works. We want the server to handle these changes automatically. This is exactly what quick turnaround is. It has both Scala and Java API. We can use any of those languages. It is also fun to code with Play framework. This makes us much more productive. Now, we're going to see a comparison between Play and Rails. Rails is also an MVC framework. Rails is to Ruby what Play is to Java. Both frameworks aim to reduce the boilerplate and enhance productivity. Rails and Ruby are not type-safe. Play is 100% type-safe. Play has a very robust multi-threading architecture. Rails up to version 4 supported only single-threaded apps. Now we're going to see real-life apps that use Play. These apps are Cloud and LinkedIn. Let's check them out. Cloud measures your score on social media based on your interactions. Cloud uses Play for all of the web app. LinkedIn uses Play for some of its projects, and they are really happy about it. Finally, we're going to take a look at the documentation page of Play 2. I think it needs improving, but it will give you an idea of what this framework has to offer. Here you can see the documentation. It has all the main concepts that we're going to learn throughout this course. We have taken the current problem with creating web apps and we ended up understanding how Play solves them. Now you'll know that Play is the right choice for creating your next web app. And that's exactly what we're going to do next. We're going to create our first web app for Play together so that you can learn all there is to know about building them. Hi. Now we understand what Play is and what it stands for. Now it's time to start learning how to use it. In this section, we're going to build our first web application. For that, we're going to create the Play project, we're going to create the model, then we're going to route requests to it, then we're going to create the controllers, we're going to use forms to post new data, we're going to make the template, and finally, we're going to run the application. The application we're going to be building is an agenda. For that, the first thing we need to do is to download Play Framework. For that, we're going to playframework.com and clicking on download. Here, we're going to download the zip file. Once we unzip it in some folder, we're going to add that folder to the path so that we can access it from anywhere in the console. I have already done that, so from the console, I can type play, and I will get this place prompt. One of play's command is play new. It will let us create the application. That is what we're going to do now. Play new agenda. Here it asks for the application name, it is agenda. And now we choose that it is a Java application. After this, I can go to agenda, and this project now exists. Now, I can type play here, an SVT console will show up. Play uses SVT for build. One of the commands that we can run in this Play console is Eclipsify. This will create Eclipse files. Let's do that. Once it finishes, we are going to have all the files to import this project to Eclipse. Now we have them. Now let's take a look at the project structure of this Play app. Let's type ls here. Play is an MVC framework. This means that it will have models which will represent entities. They will have states and behavior. These models will be changed and fetched by the controller. The controller is the one who interacts with the model, given events or triggers from the view. The view is the representation of the model. In this case, we see this as HTML in our browsers. When user clicks somewhere in the view, it will trigger an event in the controller which will then call the model. Model, views, and controllers are located in the app folder. Let's see that. Models folder is not yet created, but we will create it once we start adding models. In the public folder, we will put all the static files, JavaScripts and CSS. In the conf folder, we'll put all of our application's configuration files. In the test folder, we'll put all of our tests. Finally, project and target are used by SVT to handle our project's dependencies and build. So, we started with nothing and we ended up with a Play project created, ready to be imported to our IDE. Now, we'll be able to start coding our new web app. And that's exactly what we're going to do next. We're going to start creating the models for this application. So, we've got the Play project created and ready to be used with our IDE. Now, we need to start coding the web app. We're going to start with the models. So, in our Play project, let's create a models package. Inside this models package, we're going to create the contact class. It's important that the model classes in Play 2 inherit from model from Play. This class will give us helpers for saving and fetching classes with even. Even is the ORM that Play uses to save our models to the database. Now let's create the fields. It will have an ID, it will have a name, it will have a phone, and an email. As you can see, all the fields are public. Play Framework recommends the fields to be public as it automatically creates all the getters and the setters. Now, we're going to add annotations to our model to let Even and Play know how they need to save and fetch our models. For that, Play Framework uses JPA. So, we're going to set our contact as an entity, and then we're going to set our ID as an auto-generated value, using the ID and generated value annotations from JPA. Now we can add a finder. A finder is a helper that is added by Play to fetch information and query information easily. The finder is created this way. Here we need to tell the finder which is the type, the class of our ID, in this case it's a long, and then we need to tell which is the class of the model that it will be returning. It is a contact. And let's create it. Here we need to put the classes again, so it is long class and contact class. Now we need to configure the database and Play Framework to tell it how it will interact with our models. For that, we're going to go to the application.com. Here we have a database configuration section. And here we will state which is the driver, the URL, the user, and the password. In this case, we're going to use an H2 in-memory database. This is going to be the URL, and it will have no user and no password. So we're going to leave those commented. Next, we need to tell even in which package it can find our models. In our case, we have put all the models in the models package. So that's what we're going to tell even. We have taken an empty app and ended with the models for the application coded and configured. Now you'll be able to save, fetch, and query models from the database. Next, we're going to learn how to receive and route requests. Hi. Now we've got the model of our application finished, but you'll probably find that there's no way of accessing them through a web page. Fortunately, we can use the router to start receiving requests from users to process them later. Let's see how. The first thing we need to do is to define how the user will interact with our web app. At first, he's going to be able to list all contacts, see a particular one, and then create a new contact. Those actions from the users are the one that will trigger then the controller to fetch the models and display a new view. This is the approach in an MVC way. For that, we need to go to the routes file. In here, we define the routes with the HTTP method first, then the URL, and then which controller it will trigger and which action in that controller it will trigger. We'll see more about this later. In this case, we're going to add first the get to /contacts, and it will show all of the contacts. Then we need to get the page for a particular contact. For that, we need to send the parameterized parameter that will be the ID of the contact. For that, we just put a colon before the variable. So, a get to /contacts /ID will also return this contact. Then we need to add a new contact. For that, we will have two URLs. The first URL will only show the view so that the user can interact with it and then send the request to the controller. That one will be contacts/new. And then he will post all the information that he has filled to contacts-post. Now what we need to do is to add which controller and which action will handle each of these inputs by the user. In this case, this will be handled by the agenda list method. This one will be handled by the agenda show method, and this show will receive an ID parameter of type long. Then the view showing will be done by agenda also in the new contact method, and then this post will be in controllers.agenda.createContact. We have taken the model that was previously done and we have created some URLs to let the user interact with it. Next, we're going to learn how to process those requests with the controllers. Now we've got all of the routes for our agenda application. However, you'll probably find that we still need to create the code for each of the actions of those routes. Fortunately, we can use controllers to write the logic to be executed once a user goes to some URL. Let's see how. In the previous video, we created the routes, which represents the way that users will interact with our web app. Each route is mapped to a controller and the method of that controller. Each of these methods are called actions in Play. An action receives a request from the user and returns the response to the browser. Play uses result interface to model the response. So now let's create the controller. It will be called agenda. Each controller in Play must inherit from Play's controller class. In here, we will create the actions. The first action to create is the list action. Each method must be static, and each method will return the result as I previously mentioned. Here, what we're going to do is to use the finder from the contact model. This finder has helper methods to access the database. In this case, we're going to fetch all contacts. After this, we need to return the result to the user. Play has a lot of helpers that allow us to create this result. In this case, we're going to use the OK method. This OK returns a 200 status code and optionally receives an HTML to be rendered to the user. We will learn how to render HTML in the future, so for now, we are just going to return OK. The other action we can create is the show action. This action will return the page for a particular contact. It will receive a parameter of type long called ID. In this case, we're going to use the finder again to fetch this contact by ID. In the case that we don't find this contact, which means it will be null, we will return a not found. For that, we're going to use other play helper, which is called not found. Otherwise, we're going to return OK. In the future, we will return here the HTML. We have taken the routes already created and ended up with an action for each one of them in our agenda controller. Now, you'll be able to perform the actions that the user requests. Next, we're going to see how we can bind parameters from the request using forms to create a new contact. Now, we've got an action for each of the routes that showed some information. However, you'll probably find that we didn't create an action for the routes that create a new contact, as we need to bind information from the request for those. Fortunately, we can use forms for that. Let's see how. First, let's take a look into the routes file. The root file has two URLs to create a new contact. The first one will be used to display a form where the user can fill information that will be used to create a contact. This information will be sent to the second URL in a post as request params. We then need to bind all of those request parameters to create a new contact object and save it to the database. So now we're going to create those two actions in the agenda controller. Let's go to the agenda controller. First, we're going to create the action to display this form to the user. This is called the new contact action in our case. Here, we're going to use place form class of the type contact, as we want the user to be able to save a contact. In order to create it, we're going to use play helper method called form, and it will be used of a type contact.class. And then, in this case, we would have to return the status OK with the form which will use this contact form. As we still don't know HTML, we will just return OK for now. Now we're going to create the create contact action, which will bind request parameters to a form. Then it will get the contact object, and finally it will save it to the database. So let's first create this action called create contact. This action will first create the form just like we did before of the contact class. Then it will bind it from the request. After that, we're going to assign it to a local variable. All forms have a method called get, which will return the object that can be created from that form. We're going to do that now. This will return to us the contact. Finally, we need to save this contact. For that, we're going to use one of the helper methods that come with the contact class. Contact inherits from model. Model is a play class that will give us a lot of methods that can help us interact with even. In this case, we're going to use the save method. So here we're going to do contact.save. With this, we're finally saving the contact to the database. Now what we want to do is to redirect the user to the list of contacts. For this, we're going to use the redirect method, which is a helper that comes with play. Redirect receives as a parameter a call. How do we get these calls? The roots file is actually a Scala file, so we can let play compile this roots file and generate a roots class. This roots class has a path to each of the roots that are here. Each of these roots return a call. So what we're going to do now is to compile the project so that we can get this class. For this, in the play console, we're going to put compile. Let's put compile and let's wait for it to finish compiling. It has finished. Now we can see this roots class. Let's go there. Now here we're going to do the redirect. Here, as I said, it receives a call. So here we can use this roots dot agenda dot list. And that's it. This roots class has been created by play by itself after compiling the roots file. This is pretty awesome, right? We have taken the controller we created in the previous video and we have finished its implementation. Now, using forms, you'll be able to receive information that the user has filled in a website. Next, we're going to see how we can show information to the user using templates. Now, we've got the controller, roots, and model of the application finished. However, we still need to be able to show all of the information we have created to the user. Fortunately, play templates can be used for that. Let's see how. The first thing we need to learn about play templates is that they are just a Scala file. Each template is very similar to a function. It receives parameters from the controller and it returns some HTML, which will be rendered to the user. Play templates also comes with play template inheritance. For that, every play project comes with a main.scala.html. As you can see, this will be the base HTML for all of our actions template. This one receives a content which is of type HTML parameter. This parameter will be the content of each actions template. Now that we know this, let's create our first template. So let's create the list template. For that, we will be creating this in the views package. And we will call it list.scala.html. This is very important because this is really a Scala file. In here, the first thing we need to put are the parameters of this template. These parameters are actually Scala code. Every Scala code in a template must start with an @ So let's put @ and now let's put the parameters. They are contacts, which are of type list of contact. This is the way that generics are used in Scala. Now we need to inherit from main template. The first parameter is the title of this page, which is list of contacts, and the second one will be the HTML. In this case, in the HTML, we will put a table with all of the contacts. The header will have the name, the email, and the phone, And in the body of this table, what we're going to put is a line for each of the contacts that we have in the list. For that, we're using the for expression from Scala. As it's Scala code, we're going to first put the at, and we're going to say, for each contact in contacts, the following is going to be done. For each one of them, we're going to print a tr. This tr will have several tds. The first one will show the contact.name. The second one will show the contact email. And the third one will show the phone. With this, we're already showing the table. The last thing we're going to add is an anchor that will link to the Create New Contact page. For that, let's add this, and it will link to Create New Contact. Now, the question is, what should we put in the href? We're going to use exactly the same roots class that we used in the redirect. So, we're using at, because this is Scala code, roots.agenda.newContact, as that's the page with the form. And with that, we have finished this template. Now we can use this template from the agenda controller. In here, let's put in the OK the name of the HTML template that we're going to use. Here, that template that we wrote has been compiled, and now we can access it through the package named views. So it will be views.html.list.render. This render receives a list of contacts as a parameter. Those are the parameters that we put in the template. So let's send this. And now it compiles, and we are returning this HTML to the user. I will leave the template of the show action as a homework. Now we will do the template for the new contact page. Now let's create a template for the new contact action. We're going to create for this the new file. This template, as the other one, the first thing we need to put here is the parameter. In this case, it will be a form of type contact. Now, in order to create forms in Scala templates, we can use some helpers that Play have created. In order to use those helpers, we need to import them. So how do we import them? This is the way. Then we need to inherit from main again. The title of this page is New Contact, and in here we're going to put the HTML. Here we will use the form helper. This form receives the URL that we will going to use here. In this case, it will be roots.agenda.createContact. Inside this form, we're going to put all of the inputs that we need the user to fill. So we're going to put an input text for what? For the contact form sub name. And then we're going to add one of these for email and one for phone as well. After this, all we need is the button to submit this. This will be an input type submit, value, submit. With this, we have finished this template. Now let's use this from the controller. Let's come here and let's render this form. For this, we're going to do the same. views.html.newContact.render, and we're going to send the contact form as a parameter. We have taken all of the information that we had, and we learned a way of displaying that to the user of our web app. So now you'll be able to create HTML pages using models information. Next, we're going to see the app running. Now we've got our first web app complete. However, we still need to see it in action. Let's see how to do that. First of all, today I wanted to show you guys the show.scala.html. This is the template that I left for homework. As you can see, this is really easy. Another thing that I want to show you guys before starting the app are evolutions. In the conf file, we will get an evolutions folder. Evolutions are SQL files that will be added each time we add or remove fields from the database. In this case, we only have the first one. This was automatically generated by Even, and this creates the contact table. When we start the app, we will get evolutions not applied, which is okay. So the first time we start the application, evolutions need to be applied so that tables can be created and then we can use it. Now let's jump to the console. In here, we can now run the application. There are two different commands to run the application. There are run and new full run. Which is the difference? That new full run has quick turnaround, which is really cool. So that's what we're going to use right now. It will say that this is starting the application, auto reloading is enabled, and it is in port 9000. So let's go to the app. Let's go to localhost-contacts. This will show us that our database needs evolution. This will run the file 1.sql to create the contact table. This is okay. After this, voila, we land at our application. Let's create a new contact. We will put the name Modern, phone 555, and email gonto@gonto.com. Let's click on Submit. And voila, our contact was created. And now it is therefore listed in here. This means that the contact has been saved to the database. We have transformed our idea of creating an agenda into a real application that we can use to store friends' information. Now you'll be able to start creating your first web apps by yourselves. Next, we're going to learn how we can start testing our application. So now we've got our agenda finished, but you'll probably find that we haven't tested the application yet. That's what we're going to learn in this section. The first thing we're going to learn is how to test our model. Then we're going to test the templates that we have made. Then the controllers. Then we're going to check if the routes we have created are okay. And finally, we're going to do some end-to-end testing. As I've said, today we're going to start testing models. Play Framework comes with helpers to do that. Let's see how. Today we're going to test the contact model. What we're going to do is to create the contact model, fill in the name, the email, and the phone, save it to the database, and then fetch it and check that all fields have been saved correctly. The first thing we need to do is to create the JUnit test file. For that, let's click here. And let's add this test to the test folder. Now we have this class created in the test folder inside the models package. Before starting any test, we need to import two important things that Play asks us to do. These are the two. The first one will let us create a fake application with an in-memory database. This fake application will let us test all the things with Even. The second one gives us quite a few new asserts. These are assert that which are much readable than common JUnit asserts. So let's start our test. So let's rename this test to test contact model. Then the first thing we need to do is to run this fake application. For that, we're going to use the helper running. Running receives two arguments. The first one is the fake application. The fake application is created with another helper method called fake application. This fake application receives a map with options. In this case, we're going to generate a map with options for an in-memory database. We can do that with the in-memory database helper method. And then the second argument is a runnable. This runnable will have all the steps of our test. Let's create it. And now in here we need to put all the steps for the test. So let's create the contact model. This contact will have a name, an email, and a phone. Let's put those fields. Now, what we need to do is to extract these fields to local variables, so that after saving, we can check that these fields are exactly the same. Let's do that right now. Let's extract first the name, now the email, and finally, we're going to extract the phone. Now, let's save this contact to the database. For that, we're going to use save method provided by Play. Now that it is saved, we need to fetch this contact again from the database and check that all fields have been saved correctly. For that, we're going to use the finder. We're going to find it by ID using the ID from the saved contact. Now, let's do the asserts using assert that. First, let's check that it is not null. As you can see, assert that is much more readable. Now, let's check each field. Let's do the same with email and phone. Now we can run this test. We're not going to be able to run this test with Eclipse. Even needs classes to be enhanced. Eclipse doesn't enhance them, but Play does. Anyway, let's try to run this to see what happens. As you can see, it throws an error saying that this class is not enhanced. So, let's try running this in the Play console. We're going to type test for that, and it's going to test this model. As you can see, everything is success and the test was okay. Now, let's put here is null to see what happens when the test fails. As you can see, an error is shown here and the test is unsuccessful. We have taken the contact model and we ended testing that the objects of this class are being saved and fetched correctly. Now, you'll be able to test the models for any Play application. Next, we're going to learn how to test templates. So now we've got our contact model tested, but you'll probably find that we haven't tested the template for the list of contacts. Fortunately, we can use Play to test the templates. Let's see how. Today, we're going to test the list template. We're going to check that the contact name is displayed and that this link is displayed as well. The first thing we need to do is to create a package views inside the test source folder. Inside here, we're going to create a class for the test. So it will be list template test. The first thing we need to do is to add the two imports that I said in the previous video. Let's add them. Now, let's add our first test. Public void test template list. Okay. A Scala template, as I've said previously, is just a Scala function. Therefore, we can call this Scala function and get the HTML. That's how we actually test it. We get the HTML very similar to how we did it in the controllers. So, let's get the views.html.list.render. As you must remember, the list receives a list of contacts. So, let's create that list of contacts. A list of contacts. And let's add some contact to it. Actually, let's copy the contact creation from here. And now, let's add this new contact to the contact list. Now we can actually call this with the list. Now we can assign this to a local variable called content. Now let's start with the assets. The first thing we're going to check is that the content type of this content is actually HTML. For that, Play has a helper called content type. And we're going to check that it is actually equals to text/HTML. Now we're going to check first that the contact name is actually in this template. For that, Play also has a helper which converts this content to a string. This is content as string. And we're going to check that this contains the contact.name. Finally, we're also going to check that the link to create a new contact is also there. For that, we're also going to convert the content to a string, and then we're going to check that this contains the text from the link. Now, let's run this test. Let's type test, and as you can see, both tests, the model and the template, have run without problems. We have taken the previously created list template and we ended up testing it with a valid list of contacts. Now you'll be able to test all of the templates of your application. Next, we're going to learn how to test controllers. So now we've got our list template tested, but you'll probably find that we haven't tested the list action in the agenda controller. Fortunately, we can use Play to test the controllers as well. Let's see how. We're going to test the list action of the agenda controller. This action fetched all contacts from the DB and then rendered the list template. So, let's create a test class for this controller. Let's create a JUnit test class in the test source folder. The first thing we need to do is to copy these two imports that need to be everywhere. And then let's create the test method for the list action. As we're going to need to save some contact to the database so that the controller can get it, we need to run the fake application again. For that, we used running helper from Play. We're going to run the fake application with an in-memory database, and in the callback we're going to have our test. Here what we need to do is to create a contact and save it. We're going to get this contact, we're then going to save it to the database. Now, Play has a helper called callAction, which will call any action in any controller, and it will give us the result to test it. It is called callAction. Now, to get the ref to the action from the controller, it is always compiled into the same place. It is in controllers.roots.ref.agenda. And the name of the action. In this case, it's list. And we're going to assign this result to a result variable. Now we can do all type of asserts with this result. Let's start by checking that the result is okay. So we're going to assert that the status of the result is equal to okay. Then we're also going to check that the content type is HTML. So we're going to check that the content type is equal to text/HTML. Next, we want to check that the contact Martin Gontovnikas is actually returned in the response. So let's do that. With content as string, we get the content of this result, and we're going to check that it contains the contact.name. So here we have used the status to get the status code of the result, the content type to get the content type, and this method to get this content type as string. Now let's run this test to check if this all worked out. Let's type test in here. It's compiling our Java classes. And as you can see, it has run the agenda test and everything has run greatly. We have taken the previously created list action from the controller and we ended up testing it with a valid list of contracts. Now you'll be able to test all of the controllers of your application. Next, we're going to see how to test routes. So now we've got our controllers tested, but you'll probably find that we haven't tested the router to see if the URLs we have created are okay. Fortunately, we can use play to test the router. Let's see how. Today, we're going to test first that the new contact form route is valid and that it returns a status code of 200. Then we're going to check that when we call some URL that doesn't exist, the result doesn't exist either. Let's create these test methods inside the agenda test. So, our first test will be test new contact route. Here we're going to use another method which is from play helpers, which is called route and call. Route and call receives a fake request to make. A fake request is just an HTTP post and an URL. Let's create a fake request with a get to /contact/new. And then we're going to save this result to a variable. Now what we want to check is that the status code of this result is actually 200, which is okay. So we're going to assert that the status of this result is equal to okay. Let's run this test. It's compiling. And as we can see, it says that the test was successful. Now let's add another test. This test will test an invalid route. Public void test invalid route. So we're going to make another route and call to a /concon/tact. Now we're going to receive this result and we want to make sure that this result is actually null, as that route is actually non-existent. So we're going to assert that the result is null. Now let's test this again. As you can see, the test invalid route is run okay. We have taken the previously created routes and we ended up validating that all the URLs are okay. Now you'll be able to test all of the routes of your application. Next, we're going to learn how to do an end-to-end test. So now we've got our routes tested, but you'll probably find that we still need to make a test of all the application together. This test will include models, controllers, templates, and routes. Fortunately, we can use Play to create this end-to-end test using a test server. Let's see how. The first thing we're going to do is to create a package called end-to-end in the test source folder. And in here, we're going to create a new class called Agenda App Test. The first thing we're going to do is to include these two imports that we're going to use. Now, what we're going to test is the new contact page. We're going to test that we can get the whole page with a real server. What we're going to run here is a test server and not a fake application. So let's create the test new contact form page. In here, we're going to use again the running command, but instead of putting a fake application, we're going to create a test server. This test server method requires a port number. We're going to set it in the port 3333 so that this doesn't interact with other things. And here we're going to put the callback. Play Framework also has a WS web service helper. This will let us make a request to a URL. In this case, the URL will be localhost 3333, as that's the port that I've chosen. And here it is contact/new. Now we're going to first get the promise of the response. Then we're going to say that we're going to wait for that response. And once that it has been received, we're going to get it. This way we get the response. Now what we want to test is that this response has something in the page. So we're going to first ask for the response body. And we're going to save this in a string. And now let's go to the new contact. And let's see, for example, we can check for the page title. Now we're going to assert that the body contains this text. Now we can run this test. It is compiling our source, and as you can see, it has run the agenda app test with no error. For example, let's put an error here. Let's put something that will not be found, and let's run the test again. As you can see, this is the real body of the response from the server, and that text that we have just put is not here. We have taken the agenda application and we ended up creating an end-to-end test with a real test server. Now you'll be able to test your whole application by yourself. Next, we're going to learn how to improve our app. Now we have our basic agenda application finished. Today we're going to learn how to improve our agenda application. We're going to start validating our model, creating nested actions, and then we're going to secure our application. Right now, when you create a contact, you'll find that if you want, you can add a contact with no name or with no valid email. Thankfully, we can use Play to validate our model. Let's see how. First, let's see how our application works right now. As you can see, there are contacts which have only name and no email or phone, or some empty contacts. For example, if I want right now, I can create a new contact with just name. We are going to validate this today. In order to validate this, we need to add annotations to our model. These annotations will tell Play Framework how we want it to validate it. Some validations come built in with Play Framework, like required, max size, min size, but you can add your own. Let's add some validations to our model. We want the name to be required, in this case. We also want the phone and the email to be required as well. We also want the email to be validated and checked so that it is really an email. And for now, these are the only validations that we're going to add. Now we need to check for these validations to check if the user has inputted any error in the form. For that, we're going to use the form that we have binded from the request in the agenda controller in the create contact action. What we need to do is to check if this form has errors. If it has errors, we're going to send the user again to the contact page where he can fill again all the information. So here we're going to return a bad request, as it was a bad request, with the new contact page rendered again with this validated form. Otherwise, we're going to get the contact, save it, and then redirect to the agenda list. And this is all we need to do. Now, let's try this. Here, let's create a new contact. Let's add no name, no email, and no phone. We click submit, and bam, we got the validations from Play telling us that this field is required. Now, let's add a name. Let's add an email called name and a phone. Let's see what happens. As you can see, it is telling us that the email is not valid. Let's add a valid email. And let's see now. It all worked out. So, we have taken the previous contact model and added validations we needed via the annotations. Now, we are certain that the information in our database is consistent and correct. In the next section, we'll see how to create nested actions in our controllers and what they are used for. Now, we have our agenda finished, but we don't log the requests to debug. However, you'll find that if you want to do that now, we would need to add the line to log in every action, in every controller. Thankfully, we can create actions that can be reused by composing it to the controller's one. Let's see how. As you might remember, an action was a method that returns a result and uses the request to return it. Each action was a method inside the controller. We can actually create standalone actions if we want by inheriting an action class from Play. That's the first thing we're going to do. We're going to create a new class that extends this action class. Our action will be log request action, and its parent will be action from Play. As you see, this action receives a generic T. This generic T must be an annotation. This annotation will be used in the agenda controller above each action to say with which we're going to compose it. So now, before coding the log request action, we need to create this annotation. For that, we're going to create an interface called log request. This log request interface is going to be an add interface. So we need to add the add in here. Now we gotta configure this annotation. We're going to say that the target of this annotation, which means where it can be put, it is inside a type, which would be a class, or it will be inside a method. And then we're going to say when it will be used. After we finish with all the imports, now the only thing we need to add is to say this annotation, which action will it use? That is done using the with. And here we need to put that this annotation will trigger the log request action. Now we're all set to start coding our action. Here, this will be an action that will be triggered using the log request annotation. Now let's implement these methods. This context that we received here is actually which HTTP method in which controller we must call. So here we can do whatever we want before and after that call. And that way we're actually composing this action to any other action that we want. So for now, all we are going to do is to actually log this request. Here then, we're going to use the logger from play. We're going to log the request was called and the context was called. After this, what we need to do is to call the real context. For that, we have a delegate here. This delegate is a field that is inherited from action from play. This delegate has a call method that receives the context. This will know which action in which controller to call depending on which one was used using this annotation. And this called is what we're going to return. As you can see, now we're actually first logging this, and then we're returning the result from calling the action. If we wanted, we could assign this result to a variable and then add another log at the ending, so we can actually do anything before and after each action is called. Now, let's go to our agenda and let's add in some of the methods this annotation. So for example, we want in the list to log the request. This will tell that before calling this action, we need to call this other action, which is log request. If we wanted to add this log request to every action in a controller, which is this case, we can actually put it above the controller. This will make this action to be called before every action in here. Now, let's try this out. Now, let's go to the context URL. It first needs, as I just started the application, to run the evolutions, as we have seen in a previous section. So after applying it, we will see that it was logged that the request called was contacts. Now, let's click Create New One. As you can see, it also logs this action. This is because we have added this log request action above the controller. So, we've taken all of the actions in our controller and we've added a log to which URLs were called. Now, you'll be able to reutilize any action you want in any controller. In the next section, we'll see how to secure our application using Play's already created actions. Now, we have our agenda finished. However, you'll find that anyone can access to our application right now, so we need to add some sort of login. Thankfully, we can use Play's built-in authenticated action to do so. Let's see how. In the previous section, we learned how to create custom actions that can be reused by compositing it to any other action in the controller. So we had the log request, which we created. Play comes from an @authenticated action that can be used together with any controller or any action. We're going to use that to secure our application right now. As you can see, this is the authenticated annotation, and it receives one parameter, which is a class that extends authenticator. This class that extends authenticator is used by Play to check if the user is logged in or not. So, let's create this authenticator class. In our case, it will be agenda authenticator, which extends from authenticator. This class has a method called getUsername. This method getUsername is the most important method of this class. If we return null here, this will mean that the user is unauthorized to see the page that he's trying to access. If we return the username, then it will be saved in the session so that in subsequent requests he doesn't have to fill in again the login information. I've created a basic auth helper here, which will help us show the basic auth pop-up and to get the username and password. As you can see, what this does is to check if the authorization header is in the request. If it's not, we're sending the realm so that the browser sends us again a request but with the username and password fields. Then we use a base 64 decoder to get username and password, and then we just return the basic auth user that he has filled in. We're going to use this class in the agenda authenticator. So what we're going to do here is call the basic auth helper.auth with the context parameter. Let's change this name, and this will return us actually the user. So the first thing we need to do is to check if it's null. If the basic auth user is null, it means that he hasn't entered both the user or password, or that the browser didn't send us any of them. So in that case, we're going to return null in this method to say that he doesn't have access to get to this page. That's the first thing we're doing right now. And then, if it's not null, here we would go to the database and check if this user exists. In this case, we're just going to check for some hard-coded values. So, if basic auth user dot name equals Ngonto, which is me, and if basic auth user dot password equals Ngonto as well, then he is going to be logged in. Otherwise, he's not. So in this case, we are returning the name of this user as it did work. Otherwise, we are returning null as this wasn't correct. Now, let's go to our agenda. Let's say here that we're going to use the agenda authenticator, and that's going to be it. Now, let's try this out. Let's go to our web page, and it's asking us for the username and password. Let's put something that doesn't work. It's asking me again, and as you can see, it's giving us a page that we don't have access. Now, let's go again and let's put Ngonto, which is okay. As you can see now, I do have access to our agenda application, which is exactly what we wanted in this case. We've taken our unsecure application and we have added basic auth to it. Now, you'll be able to secure your own applications. In the next section, we'll see how and what modules are. Hi, in this section, we'll learn how to make our app even cooler. We're going to first create a custom not found page. Then we're going to make our app international so that it can reach more people. Then we're going to use Twitter Bootstrap to create the forms. And finally, we're going to deploy this so that our friends can check it out. Today, we're going to start with the 404 page. Now, if a person tries to go to a non-existent URL, he gets a not found page. However, you'll find that this default page isn't really pretty to our users. Thankfully, we can configure the 404 page using Play Framework. Let's see how. Play Framework has a global object class. We can inherit this class and override some of the methods to change some functionality in Play. We can, for example, hook to the application start, application end, and we can also change what it does with the not found. One important thing is that our global object must be in the root package for it to work. So, let's create this global object in the root package. We're going to create an object called global, which extends from global settings from Play. Now that we have extended, you can see that we have a lot of hooks here, like on bad request, on error, on request, and we're going to use one of these to code this not found page. But before doing that, we're going to create the view of not found. So let's create a new view called not found. we're going to create an HTML file called notfound.scala.html. We're going to delete all of this. And now the first thing we're going to do is to inherit from the main layout with the title, Yo, the page is not found. And in here, we're only going to put some h1 calling the page isn't there, dude. Now we're going to use this template from the global object. So what we're going to do now is to add the onHandlerNotFound hook here in the global object. Let's add it. And as you can see, this hook returns a result. This result will be the status code together with the view. As we need to use results in this case, we need to statically import all the results. For that, we can use this import. Now, let's actually return a status code not found with the view of the not found that we have created before. We need to return this, and now let's try this out. So here we have our regular contacts page. Let's go to another one like contacts pp. And here we have our custom 404 page, which is saying, the page isn't there, dude. And you can see also the title, which is exactly the one that we have chosen. So we've taken the ugly 404 page and we ended up with a nice new not found page. Now you'll be able to create nicer 404 page. In the next section, we'll see how to internationalize our application. Now we have an English agenda application. However, you'll find that users that speak other languages won't be able to use our app. Thankfully, we can configure internationalization easily in Play so that depending on browser's language, the text will change. Let's see how. The first thing we need to change here is the configuration about language in the application.conf file. Here, you'll see that the application langs for the time being are only one, N. So we're going to add S in this case, as we want Spanish language as well. Besides this, there's a file called messages in our application. In that file, we need to put all the text that we want to translate. It is like a properties file from Java. Let's edit one, which is in Spanish. For this, we're going to create two new files inside the conf directory. One file will be messages. This file will be used by default for all the messages we need to put in our application. The other file we're going to create is one very similar to this one, but called messages.s. This will be used for all text in Spanish. So, let's put now a key with a value to be translated. For example, we want to put that phone is phone in English, but in Spanish, phone is teléfono. And now, let's try this out from a page. Let's go to the list.scala, and here where it says phone, let's say, let's use the messages files from Play. How do we do that? For that we put the for play code, and then we put messages. And inside here we need to put the key of the translation we want. In this case, the key is phone. The key is this one, phone, and this one is the text. So let's put phone here, and let's now try this out. Let's go now to the browser. Let's refresh this, and it keeps on saying phone as my browser is right now in English. Let's go to settings and let's change the language. Let's say that my browser is right now in Spanish. Let's click OK and let's refresh this page. And now it says teléfono. which was exactly what we wanted. This used the browser's language. So, we've taken the English version of the agenda and we have implemented it in Spanish. Now, you'll be able to create web apps in many languages. In the next section, we'll see how to use Twitter Bootstrap with our forms. Now, we've got a functional create new contact page. However, you'll find that this page is not really nice. We're going to use Twitter Bootstrap to make it prettier. Thankfully, we can configure and use Twitter Bootstraps with Play Framework. Let's see how. The first thing we need to do to use Twitter Bootstrap is to download it. So let's go and do that. Let's go to Bootstrap page and let's download this. Once it has been downloaded, we just need to extract this. And now we have here all the CSS and all the images that we need. Now we need to add this to our application. Let's see where to put everything. Let's open our agenda application folder, and here you will see that there is a public folder. Inside here, all the images and all the JavaScripts and style sheets will be put. So let's put this also in there. Let's get the responsive CSS and the Bootstrap CSS, and let's copy them here inside the style sheets folder. And then let's get all the images here, and let's put them here. For now, we're not going to use the JavaScripts from Bootstrap. The next thing we're going to do is to configure some roots so that we can use Bootstrap's images with the CSS. As you can see, in Bootstrap, these images are in the folder img, and in Play, they are in the images folder. So, let's configure those roots. Let's go to our Java code. And here, in the roots file, we need to configure this. As you can see, there's already a root for all the assets to the public folder. So, in this case, if this goes to look to the /img, it will look for that folder. We actually need that if he's looking for the img path, it goes to the images folder. Here we have two roots. One that goes to assets img and this path, and the other the same. And this is the default URL that Place goes to look for. It is in the public directory, just like this one, and then it goes to the img. In our case, we want this to go to the images folder, and this one as well. So, this is saying, when it goes to this URL, then return this asset. And with this, we have Bootstrap already configured to be used. Now, we need to add this to the main template. Here, we need to add our CSS and our JS, if we had added it. So, let's copy this one first. And as you can see, there is a roots helper to get to all these style sheets. Why does this say asset? Because in Play, all of these JavaScript style sheets are assets, and they can go through something called asset pipeline. So, if instead of CSS, we would have wanted to use Bootstrap less file or Sass file, we could, as Play has some converters to use with them. Anyway, for now, we're just going to use the CSS for Bootstrap. So here, we need the Bootstrap and the Bootstrap responsive URLs put. So here, let's put Bootstrap responsive CSS, and let's put here the Bootstrap CSS. Now we can use Bootstrap in any page that we have that inherits this main template. Now, what we want is to use Bootstrap with our form. If we were to use it with any other component, we can put whatever we want. But if we want to use it here, we need to configure something else. As you can see here, we are just putting @input text, and it creates the label, the input text, and everything. It is something like magical. So how does this work? This input text, which is a method that creates all the HTML, receives a parameter. That parameter is a field constructor. That field constructor takes care of creating all of the HTML given an element. So, why don't we see the parameter here if I am saying that it receives that parameter? Because Scala has a feature called implicit parameters. These parameters are received implicitly in the method, and we don't see how. But if we define some implicit variable here, then the input text will receive that one. So, what do we need to do now? We need to first create this field constructor for Bootstrap, and second, we need to import that implicit field constructor in here. Let's do that. So, let's create a Bootstrap input HTML file here. It is called bootstrap input.scala.html. And in here, we're going to put the code. The first thing to add is the parameter. Every field constructor receives some field elements. This is what we're going to use to get the label, the text, and all of those parameters. And in here, using that elements, we need to put the structure of a Bootstrap field. I have already created one, so let's copy it in here. As you can see, this uses control group class from Bootstrap, and it uses elements. So for example, if the element has any error of validation, it will have the error class. Here it shows the element label. Here it puts the input that was chosen, either input text or whatever. And here all of the errors are shown with a comma between them. So now we have this created. Let's import this from the new contact page. How do we do that? Here we need to create an Scala implicit field. This is the way we do it. We put that it is going to be implicit, and then we say field, and here we create a field constructor passing as a parameter the name of the view we have created, which is bootstrap input.scala.html. Now, this field constructor will be used implicitly by this input text. Let's try this out to see if it is working. Before doing that, let's also add here to the button some class that will make it bootstrap also. So let's put that it is a button and that this is a button primary, so that it is going to be blue. Now, let's try this out. Here we have the contacts page, and as you can see, now it does look something more like Bootstrap. Let's click on Create New One, and here you can see first that the button is actually a Bootstrap button, and let's inspect the code for this input. As you can see, this has a control label, which is exactly what we put. Let's click Submit, and now the errors are shown Bootstrap way. They put the field in red, and they put here the error. And this is exactly what we wanted and we needed. Now we have Bootstrap in our application. So, we've taken the new contact page and we redesigned it using Twitter Bootstrap. Now, you'll be able to create nicer web pages using Twitter Bootstrap. In the next section, we'll see how to deploy this app. Now, we can use the Agenda app from our home at any time we want. However, you'll find that we cannot use it from any other place as we don't have access to it. Thankfully, we can easily deploy the application to Heroku to use it from anywhere and for free. Let's see how. Heroku is a platform as a service, and it lets us deploy our applications for free. If we need something further from the free service, we can pay to get it. Heroku, for free, gives us a Postgres database. So, the first thing we're going to do is to prepare our application to use Postgres instead of H2 as we have been doing right now. So, in our Agenda project, we have a folder called Projects as well. In there, There are all the configurations on how to build our application and which dependencies it has. In the build.scala, we have here all the dependencies of the application, the name and the version. If you have any dependency, you must add it here in app dependencies. In our case, we're going to add the Postgres dependency. So, we're going to delete this comment, and in here we're going to add the dependency. Let's copy it, and here we have the dependency added. Now, let's try to type play so that we get the play console. Let's load the project definition updated, and then if we compile, we should get this new dependency. As you can see, it is resolving the Postgres dependency, and once it finishes, it will be downloaded. Now, the second thing we need to do right now is to configure some other file. Heroku reads a file called procfile to know how to start our project. So what we are going to do is to create this procfile to tell Heroku that our Play application actually needs a Postgres database. Let's do that now. So we are creating this procfile, and in here we're putting this line. This is saying that we need to start the application with this port and these options. It says that we're going to use Postgres and that the URL will be provided by Heroku. After we do this, we have everything configured to now start using Heroku. Let's then add all these changes to Git so that we have everything added. And now we can start to install Heroku. If we come here, you will see that we can download the Heroku toolbuild. That is what we need to do. It is available for Mac, Windows, and Ubuntu. I already have this installed. After you've finished installing it, you need to type Heroku login. It will ask for your email and your password. After this, it will finish logging you in, and you are done. Now you can start using Heroku. If you type Heroku, you will get the list of all of the commands you can use. In our case, we're going to create a new application here. So it will be Heroku create mgonto-agenda. As you can see, it has added our application, and it has also added a remote in Git. How does Heroku work? It gives you an origin to Git where you can push all your information and it will start the server. So, right now what I can do is git push, and now I don't only have origin, but I also have Heroku. So I'm doing Heroku master. With this, I'm pushing all of my available code to Heroku, and it will know how to start this application thanks to the procfile I have pushed. As you can see, it has detected that it is a Play 2 Hub application. It installs OpenJDK, it uses SVT, and now it is resolving all of the dependencies, and then it's going to build the project. All of this is done by Heroku by itself. So now let's wait until this finishes and we will see our application running in the cloud. As you can see right now, it has finally finished. It has compiled our application, downloaded all of the dependencies, and then it has checked the procfile. It saw that it is a web, and it launched our application. And it is at mgonto-agenda.herokuapp.com. Let's see if this has worked. We're coming here, and here we're going to that URL, mgonto/agenda, and it is loading right now, and as you can see, we do get our application. So, our application is right now in the cloud, exactly what we wanted, and we can use it anywhere we want, which is very cool. So, we've taken the agenda and we have published it in the internet. Now, you'll be able to publish any website you want in the cloud. In the next section, we'll learn about modules. Hi. In this section, we'll learn a lot about modules. First, we're going to learn what is a module and how do they work, how do we use it. After we understand that, we're going to create a module and then we're going to use that module that we have created. So let's start with a little introduction to modules. Now we have all of the code of the agenda finished. However, some parts of the code are generic and we would like to reuse them in another project. That is what modules are all about. As I've just said, they are used for the usable code. We can put some code there and we can use that module in a lot of play projects in actually all of we want. And a module is very similar to a library. A module is published in a Maven or Ivy repository just like a library, a jar library that we're all used to. So, what is the difference between modules and libraries? A module is basically a play project. So, it can have HTML, JavaScript, CSS, Java code, and all of them that you want. And then, in your project, you can use any of those HTML, JS, and CSS. So, you can create a JavaScript library that you can reuse as a module. It's not only for Java code as jar libraries. The second difference is that it's deeply integrated to Play. Modules can use Play library. So, for example, they can use the global object that we have learned and they can hook to application start, application end, and that code will be executed together with the code in our application. And this is why we need to use modules. This is why we can create a module and then we can use that code for all of our projects. We don't have to repeat ourselves. So we actually do use modules for the dry principle. Don't repeat yourselves. So we've learned what a module is and why it is really good to use it. Now you'll understand when you need to create a new module. In the next section, we're going to create our first module. Now we understand why it's really good to create modules. However, we still don't know how to create one of them. That's what we're going to learn in this video. What we're going to extract in this case is the logger action. As you can remember, we created an interface and an action that logged each of the requests to debug it. This is very useful and we're going to use it in another project. So this is what we're going to extract. So now let's create the module. The first thing we need to do to create the module is to actually create a new play project. So it will be play new logger mod. It will ask me for the application name, which is logger mod, and it will be a Java application. After this, we have the logger mode created. Now we need to edit some files here. So what we're going to do is to create the Eclipsify file, just as we did with our agenda application. Once this finishes loading, we're going to type Eclipsify. It is now looking for the dependencies, it is compiling the source code, and then it will create our Eclipse files. Now that it has, let's import this here. So it is import, we're going to export an existing project into workspace, and here we're going to go repos, logger mod, and that's it. Now we have the logger mod created. As you can imagine, this is exactly the same as a regular play application. So, what is it important to take into account? First, the root files. We need to delete the root file, as if we don't, then they may go before the roots in our application, and we don't want that. So, let's delete this file. Then, the application.conf of this project is never going to be used. Actually, the application.conf file of the a real application out of this module is going to be used. If you need any configuration for your module will be able to fetch it from the configuration from the application. So we need to empty this file. Then, in this case, we're not going to have any views. So let's delete this package and let's delete this controller as we're not going to use it. Now, what we need to do is to get from here the log request and log request action, and we're going to copy them to our module. Now that we have added, we can delete them from here. As we delete them from here and we're still not using the module, we will get an error. So for the time being, we're actually commenting this line. After this, we have finished creating our module. It was really easy, as you can see. It is just like creating a new application. So, we've taken the code for the logger action and we have extracted it to a module to reuse it in our next project for debugging reasons. Now, you'll be able to extract any code you want to create into a new module. In the next section, we'll see how to use this module and how to use this log request action again. So now we've got our module created with a logger action. However, we haven't yet used it. Let's see how we can use it from our current project. So, the first thing we need to do is to publish this module. If you want other people to use it, you can publish it in a Maven or Ivy repository. In our case, we're going to publish it to our local repository. So, let's come here, and in SBT, we have a command called publish local. This will publish this repository to our local repo. As you can see, it has been deployed to our local repository. Here, I'm in the Play Framework folder, and here we have a repository folder as well. In it, we have the local. Inside here, our new project has just been deployed. As you can see here, there is a logger mod. So let's check logger mod out, and in here we have logger mod 291, and inside there we have the 1.0 snapshot, and there we have our code for this module. So we need to use this group ID, artifact ID, and version to actually use this module from our Play application. For that, let's go to our agenda, and in here, let's go to our project file, and in the build.scala, where we have previously added the PostgreSQL dependency, we're going to add a new project dependency. This dependency will be actually to our logger mod. So it is logger mod, the group ID, artifact ID is logger mod 291, and finally, our version is 1.0 snapshot. After this, we can quit this. Now, let's start play in here. Let's start play in here. It will load the new project definition and it will have the dependency. Now, let's compile this. As you can see, it just got the logger module dependency, and now we can start using it. So, now let's go to our Java code. First, let's do an Eclipseify here, so that we can get all of the new things in the Eclipse file. Now let's refresh this, and in here we should now have the log request action. As you can see, we do have it, and if we go to the source, you will see that it is inside the logger mod char, which we have created. Now let's test it out to see if this is working. For that, let's first run the application, and now Let's try going to our contacts page. It will ask for the database script to be run. And after this, we're getting to the contacts page. Let's come here, and the request was locked. However, now the code is in our module. It is not in our application as it used to be. So, we've taken the module we have created and we ended up using it in our agenda application. Now, you'll be able to use any module you create or any module that someone else creates. In the next section, we'll learn a lot about APIs, JSON, and body parsers. Hi. In this section, we're going to learn a lot about APIs and JSON. What we're going to learn is what body parsers are and how do we use them. Then we're going to consume some JSON in our agendas application. We're going to return some JSON. We're going to then call some external web services. And finally, we're going to use async results. Today, we're going to start learning what body parsers are. So, every request that comes to any web application has a body. This body can be interpreted in many ways. It can be some JSON, it can be some XML, it can be URL encoded params, it can be a lot of things, but we need to know how to interpret that body and how to convert or transform that body into a Java value. That is what body parsers are for. Play has a lot of default body parsers for XML, JSON, plain text, multipart form, among others. So, if the request comes with a content type of application JSON, then Play will know that it needs to use body parser JSON to parse this request. Otherwise, we can explicitly say which body parser we want to use. The downside of body parsers is that they can only be created in Scala. So, if we want to create a new body parser, we can only do that in Scala because it intensively uses iteratees API, which is from Play Scala. And this is the most important thing to learn about body parsers. So, we've learned what a body parser is and why they are so important for APIs. Now you understand what you're doing when you're consuming or serving JSON in your application. In the next section, we'll learn how to consume some JSON. So now we understand what a body parser is and why they are so useful. However, we still haven't used them. We can use body parsers to consume JSON and create an API for our agenda application. Let's see how. The first thing we're going to do is to create a new action in the agenda controller. This action will only receive JSON. So let's create a public static results, create contact JSON. For now, let's just return null. And in here, we can specify with an annotation what kind of body parser we need to use. In this case, we need to use a body parser of the JSON class. JSON will take care of converting the body to a JSON object in Java. It will also return a 400 status code if the content type of the request isn't application JSON. So, now that we are 100% sure that our request will be JSON, we can get it by using request body as JSON. This will return the JSON node. And now we can look for all the values that we need. We can, in this case, we need the name. What else do we need? We need the phone. And we also need the email. It is name, phone, and email. And what are we going to do? Now we're going to manually check if this validates OK. We can use JSON readers to do this all automatically then. But in order to understand how JSON works and how body parsers work, we're going to do this manually for now. So, if name is null, or phone is null, or email is null, we're going to return a VAT request telling the user you need to enter all fields. In this case, our response is a plain text. Otherwise, we're going to create a new contact and we're going to set to that contact all of the fields. So contact.name equals name, contact.phone equals phone, and contact.email equals email. Then we're going to save this contact. And finally, we're going to return an OK saying saved. And with this, we have finished our JSON implementation. Now, we just need to do one more thing. We need to add the root to this URL. For that, we're going to add a post to /contact/create.json, and it's going to the controllers.agenda. And dismiss. And with this, we have completed our implementation. Now, let's run the application and let's try this out. So, let's first go to our application and you will see that it has no email, no name, no person here. And let's now do a curl to create this contact. Okay, so here we have a curl which says that the content type is application JSON. We're going to do a post and the data will be name, Martin Gontavnikas, phone, and email here to the URL that we have defined. Let's see what happens when we do this. It says saved. And now let's reload here and voila, we have our contact created. Now let's not put one of these fields to see what's going on. It is telling us that we need to enter all fields and we haven't. As you can see, the JSON consuming is working great. So, we've taken our knowledge about body parsers and we have created an action that, given a contact JSON information, creates it in the database. Now, you'll be able to consume JSON. In the next section, we'll learn how to return JSON to the user. So, now we have an API that receives JSON and saves the contact object to the database. However, you will find that it doesn't respond JSON to the user. Thankfully, we can use play to serve JSON to the user. Let's see how. Let's now modify the create contact JSON that we created the last time. What we're going to do is to return JSON instead of this text. So we're going to use JSON to create actually a new JSON object. So how do we do that? For that, we need to use JSON from play libs. And it here we put new object. This will create a new JSON object. This object node is actually a map. So we can actually put in here, for example, result.put status fail, because in this case it has been failed to save the contact. So we're returning this status here. And in the case that everything went right, we're going to say status OK. And we're going to put that in here. Now let's call this again to see how it's working. We call this, and as you can see, it is telling us status failed, but in a JSON format, which is exactly what we wanted. So we have taken the create contact action and we ended up with a JSON version for it to be used as an API. Now you'll be able to create your own JSON APIs. In the next section, we'll learn how to call external web services. So, now we have an API for our agenda application. However, you will find that if we need to consume someone else's API, we still don't know how. Thankfully, we can use Web Services Library from Play to do it. Let's see how. So, we're going to consume some external API using JSON. For that, let's first find an API. The API we're going to use is the search.twitter.com. In this case, we're searching with a query of mgonto. As you can see, there are a lot of parameters in this JSON. So, let's first create an action here that will consume this API. So it will be some action that will be called, for example, external WS. In here, we're going to use Web Services Library from Play, which is WS. And in here, as you can see, we can put an URL. In this case, the URL we want is this one. The query parameters must be put separately. As you can see, the object that this returns can be used to post a file, post some input stream, put some file. We can also set some header, or we can set some query parameters. In this case, we want to set the query to mgonto, which is my Twitter user. After this, we want to get this response. As you can see, this is a promise of a response. What does this mean? That this is just like a future. It means that the object that I get, well, when I put get, is returned immediately. And then when that object finishes getting the URL and the body and the response, I will get an answer. So in here, I can use a map which will receive another function that will be called once the request is gotten, or we can do it synchronically calling the get. In this case, the get will wait synchronically until we get the response. This time, this is what we want. Once we get the response, we know that this is a JSON, and we're going to find, in this case, for example, let's say that we want to find the max ID, which should look something like that. And this is what we're going to return in the result. So we're going to return OK with everything we have just written. Now, all we need to do is to actually create the route for this. So we're going to do a get to ws to controllers.application.thisAction, and that should be it. Let's try this out. We're going here and we put ws. As you can see, it takes some time because it calls an external API, and once it returns, we get this number, which is actually the same as this number. So the call to an external API using Web Services Library from Play did work. So we have taken our application and we have used an external API to fetch some information. In this case, we have used Twitter. Now, you'll be able to consume any external API you need or you want. In the next section, we'll learn how to use async results. So, now we're using an external API. However, you will find that if this API takes too long to answer, the thread handling this request will have to wait until it finishes, making it impossible for this thread to handle other requests. That is because we have used the synchronical method for getting the request, which is this one. Thankfully, we can use play async result to return a promise of a response. The handler of the request will go to attend other requests while this external API is working, and once it gives us a result, the handler thread will go back and finally return the response to the browser. Async results is very useful to handle the see 10K problem, as we won't have one thread per request, which makes all servers go down. If we have 10,000 requests and 10,000 threads, we'll have just a bunch of threads handling the requests that will cycle around while they wait for responses from externals, things like API, and in the future, some database. So let's see how we can use this async result, which is actually very cool. There is one response here called async that, as you can see, receives a promise of a result. It means that once the result is returned, the promise will let NoPlay that it has finished to let the thread come and handle it. So it will be very similar to what we had before, like this, only that instead of doing get now, we're doing map. Map receives a function as a parameter. This function will handle this response and return some results. So it receives some function from a response to a result. And now it will have just one method to implement, that given a response, returns a result. And what we're going to do inside here is pretty much this. What we have done before, take the response as a JSON and then gets the max ID. So we're going to do response dot, and this one we're going to return it inside an OK result. So what are we actually doing here? We are returning a promise of a result. This promise of a result will then return the result once the response has finished, and the result will be the text of this max ID. So what we can do right now is try it out. Let's do that. So the URL is pretty much the same that it was before, and the result will be the same that it was before as well, but now it will be used using async. So let's refresh this page, and as you can see, we're getting the results again as well, but using an async result. So we have the call to the external services, and now we have made it async. Now you'll be able to make any async call you want by returning a promise of a result. Well, this is the last video of this course. I hope you have really enjoyed it. I've really enjoyed making it and talking to all of you about this great framework. Hopefully, you'll start creating apps with Play 2 now. If you have any doubts or concerns, don't hesitate in contacting me via either Twitter, which is @mgonto, or to my email, which is moren@gonto.com.r. And that's it. Goodbye, and let's talk the next time.